Hello everyone, this is Vini talking, and I'm bringing to you an exercise, a problem about financial mathematics, right? Let's see what this problem is talking about. Let's read it. For a monopolist product, fixed cost is $15. The variable cost is $30 per unit produced, and the demand function is given by P equals 450 minus 5Q. A. Find the quantity that maximizes the monopolist's profit, and B. Find the maximum profit. Well, first of all, we needed to understand some concepts related with financial mathematics, right? When we say cost, we are talking about what we need to pay in order to have a product done or produced. In this case, fixed costs, as expressed right here, can be anything. Fixed costs, maybe it's an electricity bill, the material that you use that you have to pay first in order to make a product. That means anything that you put your money in order to produce something, then you sell it after, right? Now, the variable cost is $30 per unit produced. That means that every product, every 1 unit of your product, you have to pay $30 first, right? So, we have here for now two types of costs. One fixed cost, that every time you need to produce a demand, you will pay this value constantly, will not vary, right? Fixed costs $50, for example, or euros, or any economic unit that you are familiar with. Now, the variable cost is 30 per unit produced. Now understand, if I produce one item, right? Just one item, I need $30 to produce that. I will deliver $30. If I need 2 units, 2 times $30. That means that the variable cost is exactly the quantity that you are going to produce times $30, right? When you do this kind of operation, you are knowing what is needed to produce, for instance, 10 units, 20 units of a product, 30 units of a product. You got that idea, right? This money represents here will be subtracted that the profit that you go to have with a product, because you needed to pay first in order to get something done, right? Now we have the called demand function, and this is represented by the following expression: P, that is the value of a product, right, is 450 minus 5Q, and this variable is the product quantity that you produced. For example, product quantity. When you do this, and this product quantity is what the fabric, the company is going to produce. For example, a cell company produces 10 cellulars apparels. That means that is the quantity that company produced in terms of the number of products, right? Notice that P here is the price of the product. Notice that the price diminished with the quantity, right? If I raise the quantity sold by a particular person, the price going down, right? Now, if we want to know how much we can get from a sale for a certain quantity, for instance 10, you need to do the following: produce the profit with the capital P of Q, that's a function, is Q, the quantity, times the price. That means quantity times the price. Price is the demand function. We are not considering this in this relation the costs, but we need now to subtract how much we get in terms of costs, because indeed the maximum profit is related not only with the quantity that is sold by a certain individual, but the costs that this quantity of products demands from us. So you need to subtract the variable costs right here, variable costs, that is 30 times Q, right? And we need to subtract as well the fixed cost, that is 15. Now you have indeed the profit, real profit, that you can get from to selling certain quantity of products, right? What we need to do now is substitute this demand function for the expression that is related with the quantity. Alright, let's do this. P of Q is Q quantity times, what is the demand function? 450 minus 5 times Q, right? Minus 30Q minus 50. Now, what we need to do is develop this relation, mathematical relation, in order to find an expression which results in a quadratic function. Let's see that. PQ is equal to, let's distribute that multiplication, 450Q minus 5Q squared minus 30Q minus 50. That result in minus 5Q squared plus 420Q, because we subtracted these terms to this, minus 50, right? Alright, now we're having a quadratic expression. When you see about the quadratic expressions, we notice that the first term here, Q squared, has a coefficient minus 5. So we need to separate the values of these coefficients. Minus 5. Let's remember first of all a quadratic expression in its general form: ax squared plus bx plus c. Notice that the coefficient a is besides x squared, b beside x, and c is the independent term. Now we can compare and conclude that a equals minus 5, b equals 420, and C equals minus 50. And in this case, when A is negative or less than 0, we have a characteristic parabola that represents this demand. In this case, is a parabola has this format. Take a look, right? And when we have a parabola like this one, we notice that this point here is his maximum, is exactly what is demanding of the question. Maximum profit and the quantity that maximizes the monopolist profit. In this case now, we know that is the vertex of the parabola. Well, we have two expressions that characterize the vertices. First of all, vertex is a point and has coordinate in this case x of v and y of v related to the x-axis. In this case, it represents related with the quantity, and in y of v is the y-axis related with the profit. What are the expressions of these two quantities? It's all related with the coefficients. Take a look. X of vertex is minus b over 2a. In this case, we can just substitute the value from what we have. Minus 420 over 2 times a, but a is minus 5, then minus 10. And this, remember that when we have two negative numbers, one divided by the other, the result is a positive number. In this case, we can cut these two zeros because we can simplify numerator and denominator by 10. In this case, we already have the quantity that maximizes the profit. 32 units of the product. What that means? The company needs to sell 42 units of a certain product to maximize its gains, right? Maximize its gains. But how much is this maximal gain? How much is this maximal gain? So this is the alternative A. Alternative B now. The maximum profit. Maximum profit is y of the vertices. In this case, what is the expression? Minus b squared minus 4 times a times c all over 4 times a. In this case, these expressions result in minus this value 175,400 all over 4 times a. A is minus 5, so minus 20. Finally, our maximum profit in this case is 80,707 dollars or euros or anything that use the monetary units. Alright, thank you for watching, and please don't forget to subscribe, share and like this video class. Thank you very much. See ya.